Alright guys, we are going to talk about square roots. And to actually be able to talk about square roots, well, we need to talk about powers too. Okay? Powers. So what I want you to understand here is how powers work. We know we have one base. We know that this is the base of the power. We know we have one exponent, right? And that once we take that base and multiply it, and multiply itself the amount of times the exponent tells me, then I'm gonna be able to get the power, right? Well, the connection between the square roots and powers is very powerful because they're actually inverse operations. So they're inverse operations. Of course, if we talk about square powers, right? Because we're talking about square roots. So think about this over here. I have a base, I have a exponent n, and I have a power m. Now let's just do an example. For instance, let's say 12 squared it's equal 144. This is my base, this is my exponent, and this is my power, right? How about we think about, let's say 3 cubed. We know 3 cubed is 3 times 3 times 3. So 3 times 3, it's 9. Times 3, it's 27. So that's going to be 27. Well, the relationship we have with square roots here is that, square roots for square powers, but for any other power, then we would have to use an equivalent root to it, okay? So think about this. In a root, we're going to take the exponent, and now this one is going to be called index, okay? Then the power is going to be inside, and we're going to call it subradical quantity. And whatever the answer to that is, it's going to be A, which before we called the base, right? Here is going to be called the root. Okay? So if that is true, then here we have to say that the square root of 144 is 12. Now, every time we think about square roots, we're not going to write down the 2 there. So we're just going to say square root like this. That means it's like an empty space, but what we really want to say is that is a square root. And that's going to be 12. Now, in the case of 3 cubed equals 27, then we're going to need a cubic root. Because remember, the exponent here is going to be the index here. Of what? Of 27. And that got to be 3. Okay? Now, you can take notes. This is going to be important for you. And from now on, guys, you need to memorize or to know by heart the first 25 squares. What is a square? Well, squares are all the numbers that multiply by itself get you another number. For instance, 4 is a square. Why is it 4 square? Because 4 is equal to 2 square. 100 is a square. Why is it 100 a square? Well, because 10 squared is equal to 100, right? Now, what we need to understand is all these numbers are going to be the squares, and they actually have a square root. So I can definitely say, you know what? Well, square root of 289 gotta be 17. Or I can say square root of 196 is actually 14. Right? What do we need to keep in mind, or what do we need to understand here? Well, that these squares, it's that number times itself, right? Now we have one deal here though. say for instance, I want to have the square root of 169. Yes, it's 13. But what happens with negative 13? If you think about negative 13 times negative 13, that is also 169. So you can actually work it with negative 13 as well. So that's why every square root is going to have a positive answer and a negative answer. Okay? We need to know that. Because a lot of people only think that the answer the square root gives us is positive, and that's not true. Because every time I multiply a number by itself and I'm getting an answer, that result can actually be gotten when I use a negative or the opposite number of the base as well. Okay? So think about that. If I have square root of 625, then that's going to be positive negative 25, because both actually are reasonable answers to that square root. Now this is for what I get or what I know as exact square roots. These are exact square roots. What do we do when we have inexact square roots? Let's think about this. Say for instance I want to find out what is the square root of 2, which is part of your homework. Well, I need to think about the squares that is before and after 2. So I know the square before 2 is actually 1. So I'm going to think about the square root of 1. And I know the square after the square after 2 is actually 4. So I'm going to think about the square root of 4. Now, of course, here, the square root of 1 is 1, and the square root of 4 is actually 2. So I know that between square root of 1 and the square root of 4, it's the same distance from 1 to 2. Now, square root of 2, is it closer to square root of 1, or is it closer to a square root of 2? Well, of course, it's actually closer to a square root of 2, right? Way, way, way closer. So what that means is that we have to think about square root of 3. I'm going to do sort of equivalent distances, right, to get to square root of 4. So if you think about it, we are pretty much trying to estimate how this works. This is the whole way. From 1 to 2, from square root of 1 to square root of 4. This is kind of halfway, right? So I can actually estimate that I'm going to have square root of 2 to be 1.4. How do I know that? Because I'm estimating. There is no other way, guys. Can I get the exact value? No, I cannot, because usually inexact roots are going to be infinite decimals, okay? Let's use another example. Let's see if I have square root of 33. What is the square before 33? I believe that is actually 25, which is 5. And after 33 should be 36, which is 6, right? I mean, square root of 36 is 6. Now, 33, of course, is very close to 36. So I know it's going to be past 5.5 for sure. Probably 5.8 or something like that. So I go 26, 27, 28, 29, 30, 31, 32, 33, 34, and 35. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is actually 1 per each. So I'm only 2 away, so this is definitely gonna be 5.8. Right? That's gonna be my estimation, which I was actually pretty good at the beginning. So think about that, okay? And the last one I'm gonna do, it's square root of 50. Square root of 50, it's actually the one before is the square root of 49, which is 7. And the one after is going to be square root of 64, which is 8. So, of course, it's going to be right here. Right? So it cannot be any bigger, definitely less than 7.5. Sure? And never actually greater than 7.2, because it's pretty much the next, right? Now, if you think about how many numbers do we have between 49 and 64, there are too many. 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, right? It's a lot. So I'm just gonna say this can be max 7.1. Cannot be more than that. So that's how I work it out, okay? So every time in the lesson you need to figure out or to estimate and square root that is inexact. This is what you gotta do. You have to estimate thinking about the square before and the square after, and which one of the two is that square root closer to, okay? The more numbers are between one and the other, the smaller the pieces you're gonna add. The lesser numbers we have here, the greater pieces are you gonna be able to add in terms of tens, okay? There are problems in the lesson that you just have to use this estimation process as well, or to use the exact square root.